In this video, we're going to continue with the solubility product, and we are still calculating the KSP from solubility data. So in this one, I'm told that I have a mass of 0.133 milligrams of silver bromide. I have a volume of 1.00 liters, and it wants to know what is the KSP. So with KSP for the silver bromide, it's going to form silver ions plus bromide ions. Okay. And the KSP expression is going to be the concentration of silver ions and bromide ions. And again, the brackets mean that this is in molarity. So I need to change the molarity, which molarity is the moles per unit volume. So I have to find the moles of silver bromide. So I need the molar mass of silver bromide, which is equal to 187.77 grams per mole. This needs to be in grams, so this is 1.33 times 10 to the negative 4th grams of silver bromide. Okay, I just divide by 1,000. So N is going to be the 1.33 times 10 to the negative 4th divided by the 187.77 to give me 1.33 times 10 to, oops, sorry, wrong line, 7.083 times 10 to the minus 7th moles. And the molarity is going to be the 7.083 times 10 to the minus 7th moles divided by 1.00 liters, which of course is the same thing, 1.83 times 10 to the minus 7th molar. So at equilibrium, again, this doesn't matter. This is going to be 7.083 times 10 to the minus 7th. This is going to be 7.083 times 10 to the minus 7th. So my KSP is going to be 7.083 times 10 to the minus 7th times 7.083 times 10 to the minus 7th, which of course is just 7.083 squared. But so my KSP is going to be 5.02 times 10 to the minus 13th. Again, I don't really care about the units for these, but if I did, it would be molarity squared. Now, you could also use, oh, this is the same problem, I'm sorry. We're still doing finding the KSP, okay? So I'm told that the solubility of lead 2 acetate is 3.3 times 10 to the minus 8th molar. For lead 2 acetate, it's Pb3ASO42. Okay, so this goes to form 3 leads plus 2 arsenates. Okay. Again, since this is giving me the solubility, that means that at equilibrium concentrations, this is going to be 3 times the 3.3 times 10 to the minus 8th because I have 3 of them. So, and this is going to be basically x, and this is 3x, and this is 2x, and this is going to be 2 times 3.3 times 10 to the minus 8th. So this is 9.9 times 10 to the minus 8th. And this is 6.6 times 10 to the minus 8. I hit the eraser. And my KSP expression is going to be the concentration of lead cubed times the concentration of arsenate squared. So my KSP is going to be 9.9 times 10 to the minus 8th cubed, 6.6 times 10 to the minus 8th squared. And that's what I didn't do. I didn't do these individually. Move over here. So KSP is 9.9 e to the minus 8th raised to the third. So KSP is going to be 9.70 times 10 to the minus 22nd times 6.6 e to the minus 8th squared is 4.356 times 10 to the minus 15th. And so KSP is equal to 4.2 times 10 to the minus 36th. This time, it would be basically, to get the units, it's 3 plus 2, so it's molarity to the 5th. But again, I'm not going to count off if you don't have the units for that. Okay. Now, we can also calculate the solubility given the solubility product constant. So this is basically the same thing we did in chapters 14 and 16. Now we're just applying it to a different equilibrium system. Okay. So for magnesium, so it wants to know what is the solubility of MgOH2 in molarity, because that's the molar solubility, versus in grams per liter. And I'm told that I have a KSP that's equal to 9.0 times 10 to the minus 12. Okay. So the first thing I need to do is write out my equation. So I have MgOH2 goes to form Mg plus 2OH minuses. I'm going to need to do my ice table because now I don't have just the equilibrium amount. In fact, that's what I'm looking for. That's a solid, so it's not included. My initial concentrations are 0. This is going to be X and 2X. So my KSP expression is going to be the concentration of magnesium times concentration of hydroxide squared. So I have 9.0 times 10 to the minus 12 is equal to X times 2x squared. So 9.0 times 10 to the minus 12 is still going to be x. When I square 2, I get 4. When I square x, I get x squared. So it's going to be 9.0 times 10 to the minus 12 is equal to 4x cubed. I divide both sides by the 4. So 9.0 times 10 to the minus 12 divided by 4 is equal to x cubed. So x cubed is equal to 2.25 times 10 to the minus 12. So now I need to take the cube root of both sides. And that's 2.25 times 10 to the minus 12. Now, the way that I enter this into the calculator is I enter 2.25 e to the minus 12 raised to the power of 1 divided by 3. Because most of our calculators have square root and squares, but not cubed roots. Some do have the way to do cube roots, but this is the way I just do it in general. I work on any calculator. 1.31 times 10 to the minus 4th molar. Okay. And since it just wanted the molar concentration, that's all I need there. And so that's going to be the end of this video.